So you should be returning from your Google search on discrete versus continuous. And one thing I forgot to point out to you in this analogy is if a piece of information floats into your brain, right? And there is nothing for it to stick to, right? So say you gave me some just incredibly basic piece of information about quantum physics, right? But I have never done any physics in my entire life. Right? That piece of information would come into my brain, it would float around, it would look and see, are there any drawers I could put this into? And if there's no drawers, it would just kind of poof and disintegrate. Okay, so I hope you realize that there was already a drawer in your file cabinet, right? Where you have worked with things that are discrete versus continuous, okay? I hope you got to some of those sites where you were looking at graphs, like if we did the number of tickets, right? Tickets versus cost, right? If you want tickets to say a concert, right? You're not going to buy 2.5 tickets, right? So this is data which is distinct, separate, right? Whereas if you were buying apples, right? Pounds of apples, there'd be no problem with buying 2.5 pounds of apples, right? So we might make a graph for apples and money like this, continuous, okay? So there are measurements that need to be very distinct, and there are continuous measurements. So I'm going to talk a little bit more about this when we're in class in person, and how this compares, because some of you have taken calculus, some of you haven't, and just sort of how this idea of discrete versus continuous compares to what you did in calculus. But let's move on to these logic puzzles. So basically discrete means distinct. It means countable, right? It could mean finite, but if it's not finite, at least it's countable, right? Which that might sound weird. You might say, wait a minute, are you saying that it's infinite, but you can still count it? And yes, I am, right? But that, again, that's a preview for way later in the course. Okay? I don't want to get ahead of myself. But anyway, let's take a look at these logic puzzles. And one analogy that I will often get is I took one of my kids once to the doctor's and they had a rash on their face. And so I was asking the doctor, you know, what should I do? Should I put some cream? Should we try to treat it? And the doctor says to me, well, if we leave it alone, it's going to do one of 3 things. It's either going to stay the same, get better, or get worse. And I thought, well, gee, doctor, thank you for that insightful analysis of the problem. Right? But I find myself using that example in mathematics over and over again, because sometimes we have a finite number of possibilities, right? And so if the doctor could guarantee me, you know what, his rash is not going to get worse, right? Then I'd say, oh, well, if his rash can't get worse, then it's either going to stay the same or get better, right? So when you have this finite number of possibilities, then process of elimination works. So let's just look at a couple kind of fun puzzles. And again, we're really just previewing some things in the course here. We're just doing some things that get your mind starting to turn, the wheels of your mind turning in the right direction. So let's take a look at, and just so you know, all 3 of these next puzzles have one and only one solution. Okay, so let's look at this case. We've got 3 people. Who's lying and who's telling the truth? And so we have a distinct number of possibilities, right? Person A is either lying or telling the truth, right? Same thing with person B, same thing with person C. So there's only 6 possible things that could happen, right? If we realized 5 of the scenarios don't work, we could use process of elimination, okay? So if we were to start in this case and say, person A must be telling the truth. Okay. So I'm gonna, and I made different ways of organizing this because, you know, if you might like this way of organizing it, or you might want to come over here and say, well, okay, there's 6 possibilities. What are they? Right. I listed them all like this, or you might say, well, what could happen? Right. Possible things that could happen. The rash could either get better, get worse, or stay the same. What could happen with these 3 people? They could all be telling the truth. They could all be lying. Right? Or we could have some other combination of 1 person's lying, 2 are telling the truth, or 2 are lying and 1 is telling the truth, right? We have all of these possibilities, right? So we could have something like this person's lying and both are true, right? Or we can say this person's true, this person's true, this person's lying, right? I mean, all sorts of possibilities, okay? So let's just start talking about this. Person A says persons B and C are both lying, okay? So that would mean that for this person to be telling the truth, this would have to be the case, right? Well, does that work? Okay. Person B says exactly one of the other two are lying, but they're lying when they say that, okay? So what is the opposite of saying exactly one of the other two are lying, right? Is the opposite of that they're both telling the truth? Think about that carefully, because right now I'm saying, okay, if person A is telling the truth, this is a lie right here. What does that really mean then for this to be a lie? All right, maybe pause the video and think, because I know this gets a little bit, you probably need a minute to process this, right? You're getting some double negatives here and things like that. So if person B is lying, what that actually does mean is that it's not the case that exactly one of the other two are lying. So either both are lying, but it could mean both are telling the truth, right? Because there's three different things that could happen. If you're talking about two people, we have three scenarios. Both are lying, both are telling the truth, or exactly one is lying, which would leave exactly one telling the truth. Okay, so again, we've got this finite number of possibilities. So I hope you recognize here that this is inconsistent, right? That both are lying. Well, that can't be the case because we already said person A is telling the truth, or both are telling the truth. Well, that can't be consistent with the fact that for this person to be telling the truth, this person has to be lying, right? So we ran into a contradiction. We ran into a case where we say, hey, these two things cannot simultaneously be true. Okay, so what we're able to do then is say, okay, well, by process of elimination then, this scenario where person A is telling the truth and person B and C are both lying, which what we have to consider then is that for person A to tell the truth, I mean, what could happen? If person A tells the truth, so this doesn't work, it requires person A and person B to both be lying, right? So any of these situations, I haven't listed them all, but I could have. Let me extend my page. So anything that starts with, so what scenarios, I only need one more, right? What scenario have I not started with? I should have three of each. I don't have false, false, true. So notice there's no way person A can actually be telling the truth because it doesn't work for these guys both to be lying. But that's what person A says. And so it wouldn't work for like this case. They can't all three be telling the truth, right? Right? Because person B says exactly one person's lying. So this can't be, right? This can't be. So I'm doing process of elimination here. So what that tells me then is, well, person A can't possibly be telling the truth. Well, there's only two possibilities. They're either telling the truth or they're lying, right? There's no kind of sort of thing. All right, and we're going to talk a little bit more about that as we get into our first major learning segment, where we start talking about what are called propositions, things that can be unambiguously labeled true or false, right? Where there's no, well, kind of, sort of, right? It's kind of like you're either pregnant or you're not. A tumor is cancerous or it's benign. It's not kind of cancerous, right? Something is either true or it's false. There's no kind of, sort of. All right, so person A is lying. We know that. Okay, so then what does that mean about person B and person C? So why don't you pause the video, see if you can finish this, and then come back in and get the solution. So I hope you really did stop to finish. It probably didn't take you too long, and didn't just stay on without thinking about it. But what you probably realized pretty quickly is that the only consistent statement would have to be this case, where B and C are both telling the truth, right? So this person's lying, and then they say exactly one of the other two are lying. Well, there we go. There's the exactly one. And person C says, at least one of the three of us is telling the truth, right? At least one, right? We have two people telling the truth, but remember the difference between exactly one and at least one, okay? So those are very important words to focus on. So I hope you have fun with some of these puzzles. They can be kind of interesting and fun. I know my idea of fun and your idea of fun might be a little different, but I think they're kind of fun. So thanks for hanging in here till the end.